How transformers work, the brains behind ChatGPT. The problem, sequential models. Here's an input sentence. Traditional models like RNNs process words one by one, in sequence. Information gets lost over long sequences. The first words become as the model processes more text. Solution, transformers. Transformers solve this with, attention is all you need. Step 1, word embeddings. First, words become high-dimensional vectors. For example, the word cat becomes a list of numbers that represent its meaning in mathematical space. Step 2, self-attention. Next, the model uses self-attention. The word cat pays attention to other words with different strengths. Multi-head attention. The model uses multiple attention heads. Each head learns different relationships, one might focus on syntax, another on semantics, and another on positional relationships. Transformer architecture. The full architecture has encoder stacks that understand the input, and decoder stacks that generate output. Information flows between them through attention mechanisms. Positional encoding. Since transformers process all words simultaneously, they need to know word order. Sine waves encode positional information, telling the model where each word appears in the sequence. ChatGPT in action. When you type a prompt like, "the weather today is," the transformer processes the full context. Each word is predicted from the complete input, generating responses like, sunny and warm. Transformers revolutionized AI by enabling ChatGPT and modern large language models. They provide parallel processing, better long-range context, scalable architecture, and form the foundation for modern AI.